Good day, class. Welcome to another lesson. The topic today is synthesis reactions. My name is Jenny, and I love science. I like to make videos to help you understand concepts in biology, chemistry, and physics. To receive my latest video, please subscribe and click on the bell icon to be notified of my latest post. Why are reactions classified into classes? Think about why scientists classify plants and animals. Around which two animals would you be more cautious? Did you mentally classify the animals before answering? Just as there are thousands of species of animals, there are thousands of chemical reactions. It is realistic to classify chemical reactions into categories. 5 types are common: synthesis, decomposition, single displacement, double displacement, and combustion. In this lesson, we are going to expand on synthesis reactions and the 3 kinds of synthesis reactions. The most important thing, don't forget to click the like button to help me with the YouTube algorithm so that more people can see this video. What are synthesis reactions? Substances combine in a synthesis reaction. This type of reaction is also known as combination reactions because a single product is formed by combining simple materials. This type of reaction can be represented by the general equation A plus B produce AB. This type of reaction can be represented by the general equation A plus B produce AB, where A and B can be an element or a compound. And AB could be a single compound. This is your hint for identifying synthesis reaction, where one single compound is produced. The following illustrates several kinds of synthesis reactions. What are the 3 kinds of synthesis reactions? The 3 kinds of synthesis reaction include the reaction of elements and oxygen, the reaction of metals with halogens, and the reaction with oxides. The first kind of reaction, the reaction of elements with oxygen, will produce the oxide of the element. Almost all metals react with oxygen to form oxides. For example, when a thin strip of magnesium metal is burned in an open flame, it produces a bright light. When the magnesium strip is completely burned, a white powder is left, and this is known as magnesium oxide. The equation for this reaction is as follows: magnesium reacting with oxygen to produce magnesium oxide. Just like magnesium, the other group 2 elements react in a similar manner to form oxides with the formula MO, where M stands for metal. In group 1 metals, the oxide form has the formula M2O. For example, lithium oxide with the formula Li2O. The group 1 elements react with sulfur to form sulfides with the formula M2S. And the group 2 elements also combine with sulfur to produce sulfides with the formula MS. Examples of this type of reaction are shown here. Some metals, such as iron, combine with oxygen to form oxides. In the product of the first reaction, iron is in an oxidation state of +2. In the product of the second reaction, iron is in an oxidation state of +3. Non-metals also undergo synthesis or combination reaction with oxygen to form oxides. Sulfur, for example, reacts with oxygen to form sulfur dioxide. When carbon is burned in air, it forms carbon dioxide. In a limited supply of oxygen, carbon monoxide is produced. Hydrogen reacts with oxygen to form dihydrogen monoxide, also known as water. The second kind of synthesis reaction is the reaction of metals with halogens. Most metals react with group 17 elements, group 17 as known as the halogens. They form either ionic or covalent compounds. Group 1 elements combine to form ionic compounds with the formula Mx, where M stands for the metals and X for halogens. Examples of this reaction include the reaction of sodium and chlorine to form table salt, and the reaction of potassium and iodine. Group 2 elements also react with the halogens to form ionic compounds with the formula Mx subscript 2. Here are some examples. The halogens also undergo synthesis reactions with almost all metals. Fluorine, in particular, is very reactive and it combines with most metals. For example, fluorine combines with sodium to produce sodium fluoride. And the third kind of synthesis reactions include the reaction with oxides. Active metals are highly reactive. Oxides of active metals react with water to produce metal hydroxides. Calcium oxide, also known as lime or quicklime, is manufactured in large quantities. The addition of lime to water produces carbon hydroxide, which is also known as slake lime. This is a crucial step in the setting of cement. Many oxides of nonmetals in the upper right portion of the periodic table react with water to produce oxyacids. For example, sulfur dioxide reacts with water to produce sulfurous acid. In air polluted with sulfur dioxide, sulfurous acid further reacts with oxygen to form sulfuric acid. This is a main ingredient for acid rain. Certain metal oxides react with non-metal oxides to form salts. For example, calcium sulfide is formed from the reaction of calcium oxide and sulfur dioxide. I will love to hear from you. Please add your questions in the comment section below and I will answer them personally. In conclusion, there are three kinds of synthesis reactions. Number 1, the reaction of elements with oxygen and sulfur to produce the oxide of the element. Number 2, the reaction of metals with halogens to produce ionic or covalent compounds. And number 3, the reaction with oxides to produce metal hydroxides, oxyacids, and salts. Thanks for your support. You'll see me in the next video. Bye!